Hello students, good morning to all of you. So today we are going to discuss about another important concept in current electricity. Okay, so today topic is a very important concept. Okay, so that is resistance. In the current electricity, most important basic concept is resistance only. Okay, resistors in series combination, resistors a parallel combination. Okay na, so what are the carbon resistors, color coding, right? So what is first of all resistance, what are the factors of resistance, right? What is the essence of resistance? So this and all will come in this session. Okay, so based on that some problems also I will give you in this session itself only, right? Okay, so first concept is resistance. What is the meaning of resistance? What is the meaning of resistance? Resistance is nothing but, you know already what is the resistance, which is the oppose the flow of electric current in the conductor, which is the oppose the flow of current, which oppose the flow of current, then flow of charge. The flow of charge is nothing but current only, right? That's why directly I have given the oppose the flow of current only, right? So which is the oppose the flow of current in the conductor is known as, so what is that? Resistance. Correct only, right? Resistance. What is the meaning of resistance? What is the meaning of resistance? See, resistance, one more definition. What is resistance? Resistance of a conductor is defined as, resistance of a conductor is defined as the ratio of the potential difference, the ratio of the potential difference across the conductor to the current, the ratio of V by I. The shortcut definition, what is that? The ratio of V by I, potential difference across the conductor to the current flowing through conductor, current flowing through conductor. The ratio of potential difference across the conductor to the current flowing through the conductor is known as resistance, is known as resistance. Correct only, right? So for example, here I have one of a conductor. So one of a conductor like that we are having. This is the resistor. This is the not a resistance. Resistor. Resistor is different. Resistance is different. Resistor is the device. Resistor is the device which is having opposing nature. Which is having opposing nature. Which is oppose the flow of current through it. The current is flowing through it. The current can oppose. That opposing nature is known as resistance. Are you clear? The opposing nature, that nature is known as resistance. That device is known as resistor. The device is known as resistor. So many resistor we are having. So what is that? Manganese, tungsten. Yes or no? So these and all some examples of resistor. Okay, later I will give you this is. So now this is the one of your resistor. This is the symbol of resistor. Remember, this is the symbol of resistor. Right, which is having opposing nature. So now here this is the battery positive charge, this is the negative terminal. Positive and the negative terminal. The current is flowing in this direction. The current I is flowing through resistors. We can represent it as R itself. So now current is flowing like that only. Now this conductor resistor is having opposing nature. That opposing nature is known as resistance. The resistor is having opposing nature, oppose the flow of current through a conductor. Through a conductor is known as resistor. Is known as resistor. Okay. So that is the meaning of resistor. So many applications also will be there. Yes or no? Yes, sir. What is the use of this resistance, sir? So many uses will be there. Correct? So later I will give that is. So first definition you can understand clearly. What is that? The ratio of potential difference across the conductor to the current flowing through conductor. Current flowing through conductor is known as resistance. Is known as resistance. So formula R is equal to V by I. R is equal to V by I. Okay, so R is equal to potential. This V is nothing but potential difference. I is equal to current. Where R is equal to what is that? Resistance. R is equal to resistance. V is equal to potential difference. Potential difference. I is equal to current. I is equal to current. This is the very simple definition. Very simple definition. Right, which is opposite flow of electric current. Right, okay, next. SI unit of resistance. What is the SI unit of resistance? SI unit of resistance is nothing but ohm. What is that? Ohm. Is actually we can call it omega. Is a omega, but we can call it the ohm like that one. This is the, so honorably they are given ohm name only, right? GS ohm. So in his name they are given honorably ohm. But this is omega. The symbol is what? Omega. Right. Okay. So R is equal to V by I. V we can measure in volt. Current we can measure in ampere. Volt to per ampere is nothing but ohm. Very clear? So what is the meaning of ohm? Ohm is volt to per current. Volt to per ampere. Volt per ampere. SI unit of potential difference is volt. SI unit of current is ampere. So volt to per ampere is nothing but ohm. Alright? Okay. So next question is define SI unit of resistance. Define SI unit of resistance. That means define 1 ohm. When we will say 1 ohm? When we will say 1 ohm. So simple meaning. What is that? 1 ohm is equal to 1 volt by 1 ampere. Correct? That means, so the potential difference across the resistor, across the conductor is 1 volt. Through that conductor, current is 1 ampere. In that case, the total resistance we can say 1 ohm. The total resistance we can say 1 ohm. Correct only, right? So definition we can say that. What is that? The resistance of a specimen is said to be specimen resistor. So the resistance of a specimen is said to be 1 ohm. 1 ohm. If 1 volt potential difference across it causes a current of 1 ampere. The current of 1 ampere to flow through it. If 1 volt potential difference across it causes a current if 1 ampere flow through it. Alright, that means, so the wire is having 1 ohm resistance. 1 ohm resistance. When we will say 1 ohm resistance, that means we have to send 1 volt. We are having 1 volt potential difference across this conductor. In that case, 1 ampere current is flowing through this conductor. 1 ampere current flowing through this conductor. That is known as 1 ohm. Right? In that time we will say 1 ohm. So 1 volt per 1 ampere is nothing but 1 ohm. So that is why here I have written 1 ohm is equal to 1 ohm. 1 volt by 1 ampere. Very good definition. Remember everybody. 1 ohm is equal to 1 volt per 1 ampere. That, yes, finished. Next one, dimensional formula of ohm. Dimensional formula of resistance. Dimensional formula of resistance. Okay. Dimensional formula of resistance. Right? Okay. Resistance. What is the SI is? Volt per ampere only, right? Volt per ampere. So volt we can write it joule by coulomb. Joule by coulomb. Why? Because so potential difference, potential for what is the potential? W by Q only, right? Potential is equal to W by Q. W means work done by charge. So therefore this is the joule by coulomb. That is why here instead of volt I have written joule by coulomb. So ampere. Directly volt we can't write, right? Yes, sir. Dimension form. Dimension form we want to write in the MLT form only. So that is why volt we can convert joule by coulomb. Joule by coulomb. So ampere only. Right. Joule dimension formula. L square T power minus 2. Yes. Then. So coulomb dimension formula AT. Ampere into second, AT into ampere. Therefore, ampere into ampere, ampere square. So T goes to numerator, becomes T power minus 1, T power minus 2 minus 1 minus 3 will come. Therefore, finally, dimensional formula is m L square T power minus 3 A power minus 2. A power minus 2. This is the dimensional formula of R. Dimension formula of R. Okay, the next one, it is a scalar quantity. Remember, very very important. Resistance is a scalar quantity. Resistance is a scalar quantity. Next, the symbols of resistor. The symbols of resistor. So, fixed resistor symbol we can represent like that one. This is a fixed resistor. Similarly, one more will be there. What is the variable resistance? Variable resistance. Fixed resistance. This is fixed resistance symbol. Resistor, this one. Fixed resistor. Fixed resistor. Similarly, variable resistor. Variable resistor. Just very very simple. What is that? So that is the rheostat. Okay. So fixed resistor. This is the variable resistor. Variable resistor. We can represent like that. Right, this is the small information about resistance. Resistance definition, dimensional formula, as well as SI unit, okay, and physical quantity. It is the scalar quantity. And symbol of resistor. So two symbols are having fixed resistor as well as variable resistor symbol. Are you clear? Right. Next, what are the factors affecting the resistance? Next factors. Right. Next, factors. Factors affecting the resistance of a conductor. Factors affecting the resistance of a conductor. What are the factors? Okay, what are the factors? How can we increase the resistance? How can we reduce the resistance? Okay, these are the factors. So, first factor we are having, what is that? The resistance of the conductor is directly proportional to the length of a conductor. Length of the conductor. Okay, so first one is, what is that? Length of the conductor. For example 1 I have given. So this is the, what is that? Resistor. Okay, this is the L is equal to length. Length of conductor is how much will be there? So 2 centimeters will be there. 2 centimeters. Similarly here. So resistor this much will be there. So this is the nearly 4 centimeters will be there. 4 centimeters will be there. So for example, this is the length is more mean, length is less mean, then what happened? The opposing nature is less only. Correct? That means strength should be decreased, right? So length is more mean, so opposing nature is more. Length is less mean, opposing nature is less only will come. That is why here, so the resistance of the conductor is directly proportional to the length of the conductor. Length of the conductor. So the length is more mean, the resistance also more. This is the resistance R1, this is the resistance R2. Therefore, R2 is greater than R1. Why is the R2 is greater than R1? That is depends on length only. The length is more mean, the resistor is having more length. In that case, the resistor is having more resistance nature, resistance power. Alright? That is why here R is proportional to L. R is proportional to L. Therefore, we can write it formula R1 by R2 is equal to L1 by L2. One of the most important formula, this one. Right? First observation we can observe. What is this? Depends on length only. The length is more, be resistance also more. Alright? Similarly, for small change of length, what is the relation? So, delta R by R is equal to delta L by L. Okay, small change. Okay, in the units and dimensions I have given so many times these formulas. The change in length by original length. The change in resistance by original resistance is nothing but we can call it, what is that? Small change of length. Small change of length. This is the first factor now. The resistance of the conductor is directly proportional to the length of the conductor. Right, finish. So next one. The resistance of a conductor is inversely proportional to the area of cross section. Area of cross section means thickness. The thickness of conductor is increased mean the thickness of conductor increase mean the resistance power should be decreases. Are you clear? So for example here, so this is the one conductor. Okay, resistor, conductor in the sense here resistor. So now I can increase the thickness like that only. So thickness should be increases. In that case, what happened? The resistance power should be decreases. Remember, this one is very important. What is that? R is inversely proportional to the area of cross section. Inversely proportional to the area of cross section. Okay. So R 1 by R2 is equal to A2 by A1. A2 by A1. Okay. So for small change, for small change in area, purpose, we will give you formula delta R by R is equal to delta A by A. So this one also you can remember formula, very important for small change. Still we can write it here. Area is proportional to, so this is a look like a circle only, right? This is a look like circle, and that is the radius. If I consider small r mean, then what happened here? Pi into r square. So proportional, no? That is why here. So r is proportional to r square. Small r square. R is equal to radius. Radius of a given cylinder, given wire. Given wire is the circular shape only. That is why pi r square area. Okay, now so that is why here what we read here, r is proportional to 1 by small r square. Then r1 by r2 is equal to r2 by r1 whole square for small change in radius. For small change in radius. So then what happened here? Delta r by r is equal to, according to, what is that? So power error. Yes or no? What is that? 2 into delta small r by small r. Correct? Did you remember this one? Power of error. Errors in power. So this is becomes twice multiplication, right? 2 into delta r by r, small r. For so any power, you know already in the units and dimensions I have given this and all. So power is there, mean we have to write in formula like that itself. Delta r by r is equal to 2 into delta r by r. This is the second factor. What is the second factor? So the resistance of a conductor is inversely proportional to the area of cross section. Area of cross section. Right. Now third factor. What is the third factor? Third factor I have given there. So that is the temperature related topic only. Temperature related topic. What is that? See what's here. So as the temperature increases, the resistance of a metallic conductor, what would be happen? What would be happen? Is a conductor. Now I have given so amount of heat energy. That means I will send the current. So what happen? This body will get automatically thermal energy. Okay. The temperature can increase, mean the resistance what would be happen? The resistance what would be happen? Increase or decrease? Alright. So remember here. So what is that? The conductor increases. The resistance of a metallic conductor is increases. Why sir increases? What is the reason behind that? Yes. Why? Because for example here I have one of a conductor. Okay. So now this is the battery will be there. So now, so this is the positive charge, this is the negative charge. Correct? Here positive ions. Positive ions are moved from positive terminal to negative terminal. Here negative ions will be there. These negative ions can move from negative terminal to positive terminal. Okay. So temperature is a normal condition. In that case what happened? It can move in this direction. So what happened here? This is the positive ions. and this is the negative ion, so collides each other. So it will take some relaxation time also. Correct? So here, so what is that? Vibration is less will be there. Remember here, most important word is the vibration. At a normal temperature, the vibration of molecules is less only at normal temperature. So that this vibration is very less will be there. Therefore, these electrons will come, can hit here, again will goes like that only. Correct? So that means relaxation time is, so what happened here, less only. It can hit and again comes here, will go like that only. Correct? When I give high potential, what would be happen? The conductor will get heated. In that case, the vibration of these ions, positive ions, the vibration is increases. So the vibration is increases. So like that. For example, here is a positive ions will be there. Yes or no? So here negative ions will be there. Negative ions want to reach this positive terminal. So positive ions can reach the negative terminal only. Like that is the situation. It's the flow of charged particles. Correct? So vibration is increases. Mean what happened here? So for example, this electron will come here. The proton will go this side. Yes. So it can observe. It can. So here required. What is that space? What space is required? The gap is required. This gap. Okay, there is no vibration. What happened? So some gap. So easily it can observe. It can find. But now vibration is more will be there. Vibration is more. This one. So like that. So can vibrate. Can vibrate mean these electrons cannot to go so this direction. Mean it can very difficult to find a path. Very difficult to find the path only, right? Why? Because so if I go this side, mean again this one will come like that only. If I want to go this side, mean again this I want to go this direction, mean this positive ions will go this side only. Vibration. The vibration is increased. Mean the electrons cannot reach easily this end. Cannot reach easily that end. That means the flow of electrons, it will take more time. Correct? So opposing nature is more will come here. So this vibration is there. Vibration is more mean what happened here? So that opposing nature is more will come. Correct? So relaxation time is here. So can hit, again will go, again hit. But here relaxation time is more. But what would be happen here? So here relaxation time is compared to this one. Here more, here very less. Yes or no? Why? Because here particle will be there. So this is the electron. Electron can hit. Again will come, again hit. Yes or no? The average time between two successive collision. Here there is no vibration. Therefore what happened? So initially can hit here. Again will come. Again one more time can hit here. That means up to here to here some time will be there. Correct? That relaxation time. But here relaxation time is very less. Why? Because so molecules are very near will be there. That means vibration is more will be there. Can hit here, again hit here. Can hit here, again hit here. That means here relaxation time should be decreases. Okay, the resistance can increase, mean the relaxation time should be decreases. Remember this formula. Already I have given us last class also formula. What is that? R is equal to m, yes or no, by L into N E square into tau. Like that I have given, right, formula. So what is that? That formula I have given. So deduce Ohm's law. R and time. So both are inversely proportional. Correct? Resistance increase mean so relaxation time should be decreases. Correct? So that one is important. Very important this point. The Temperature can increase mean the resistance should be increases. Okay, the resistance should be increased mean relaxation time should be decreases. Relaxation time should be decreases. This is a very important point, this one. Alright, so that the temperature can increases in the resistance of a metallic conduct. Sorry, the temperature increases. Resistance of metallic conductor should be increases. Temperature and resistance. Temperature can increase mean resistance also can increase. Resistance can increase mean relaxation time should be decreases. Relaxation time should be decreases. Are you clear? This is a small relation I give it. Extra relation this is. Alright. So these are the some factors. As the temperature increases, the resistance of a metallic conductor increases. And that of semiconductors is decreases. Semiconductors is decreases. Okay. So for example, if I consider here graph also. Graph resistance and temperature. So the graph will come like that only. For copper molecules, copper particle. If I consider what is the nichrome wire, so it will comes like that only. Straight line will come. Is the resistance can increases. Resistance can increase. So, but in semiconductors, the resistance power should be decreases. Why? Because at low temperature, these are the act as a insulator. In that case, resistance is more. Correct? Insulator means resistance is infinity. Yes or no? So, next one. So, next what is that? The temperature can increase mean what happened? The resistance power should be decreases in the semiconductors. Okay, at high temperature, semiconductors act as a conductors. Semiconductor act as a conductors. At a low temperature, act as an insulator. Okay, the gap. So this is that is the other topic, that semiconductors. I want to go that side. So just you can remember what is that? The temperature can increase mean the resistance of semiconductors should be decreases. Should be decreases. Right? So this is the conductors. Is the conductors. In semiconductors is the temperature, this is the resistance, decreases. In semiconductors, the resistance is decreases while increasing temperature. While increasing temperature, the resistance should be decreases in semiconductors. But in conductors, the resistance should be increases. This is the, what is the resistors? What is that? Resistors. Nichrome, okay, manganese, this and that. So the resistance directly proportional to the, so what is the increase in temperature. These are the factors. Are you clear? So factors are three I have given. One is, so R is directly proportional to the L. Second one, R is inversely proportional to the area of cross section, and R is directly proportional to the temperature. R is directly proportional to the temperature in conductors. And R is inversely proportional to the temperatures in semiconductors. Remember this point. Okay, right. Next. Right. So now conductance. Next topic is conductance. What is the meaning of conductance? Conductance is nothing but the reciprocal of resistance. Simple definition. The reciprocal of resistance is known as conductance. Right? Okay. So what is the meaning of conductance? Conductance is nothing but a reciprocal of resistance. It's called conductance. The reciprocal of resistance is called conductance, which is represented as G. So G is equal to 1 by R. 1 by R. 1 by R is nothing but resistance. Oh, sorry, conductance. G is equal to 1 by R, where G is equal to, what is that? Conductance. Remember my everybody. So simple definition. The reciprocal of resistance. What is the SI unit? SI unit is equal to 1 by ohm. So SI unit is what? 1 by R is equal to ohm. Alright? Ohm inverse. Ohm inverse is the SI unit of G. Alright? That is, we can call it like that. What is that? So, reverse ohm. Reverse ohm. So, ohm is like that only now, ohm. So, reverse ohm is MHO. Mo. We can call it, what is that? Mo. Mo is the SI unit of conductance. SI unit of conductance. We can represent as ohm inverse. Is nothing but Simon. George Simon. Right? GS ohm. So there is the Simon. Simon is the SI unit of conductance. Ohm inverse means Simon. Remember, Simon, what is that? Simon is nothing but ohm inverse. Simon means ohm inverse. Okay. Next, dimensional formula. Dimensional formula of G. So reverse of resistance only, right? Resistance dimensional formula, you know what is that? M L square T power minus 3 A power minus 2. This is the dimensional formula of R. Now 1 by R. 1 by R means, so 1 by. So all goes to numerator, becomes like that one. What is that? M power minus 1, L power minus 2, T power plus 3, A power minus 2 is becomes plus 2. This is the dimensional formula of conductance. Right, that is a finished mark. So next, very important definition of the definition. What is that? Resistivity. What is the meaning of resistivity? Resistivity is nothing but the resistance per unit length. The resistance per unit length is known as resistivity or specific resistance. When we will say specific resistance, when we will say the resistance is specific resistance, the resistance is specific resistance, when we will say, right, for that first small derivation, what is that? We know that R is proportional to L only, correct? So factors affecting the resistance of a conductor. R is proportional to L, R is inversely proportional to A. So from 1 and 2, what we can write? R is proportional to L by A. L by A. Where proportionality we can consider rho. Proportionality constant is rho. R is equal to rho into L by A, where rho is equal to specific resistance or resistivity of a given material, resistivity of a given conductor. Okay, so rho is the resistivity or specific resistance. Alright, when we will say rho is equal to R, that means specific resistance is equal to resistance. Right? So if L is equal to 1 unit, that means 1 meter, and A is equal to area of cross section of a given conductor is 1 meter square, then what happened? So the 1 get cancelled, R is equal to rho will come. Right? In that time, this resistance is called specific resistance. The length of conductor is 1 unit. The area of cross section is 1 unit. In that case, the resistance R is equal to rho, means specific resistance. When the L is equal to 1 unit, A is equal to 1 unit square, in that case, the resistance is equal to rho. That R is nothing but, now we can call it a specific resistance. So that is my definition I have given like that. What is that? The resistance of a conductor of, the resistance of a conductor of unit length and unit area of cross section is called specific resistance. Specific resistance. The resistance of a conductor, we will say specific resistance when, so the length of wire is 1 unit and area of cross section is 1 unit square. In that time, we will say the resistance is equal to specific resistance. Alright, so specific resistance or resistivity of the material of conductor. Material of conductor, that is the resistivity or specific resistance. And one more shortcut definition. What is that? The resistance per unit length. The resistance per unit length is called resistivity. The resistance per unit length is called resistivity. Alright, then what is the formula? So what is the formula? Formula is, we can write it like that. What is that? R is equal to rho into L by A, right? I want to rho. Rho is equal to what will come? So transfer this side, R into A divided by L. Divided by L. That means resistance is equal, resistivity is equal to R into A into L. Remember, resistivity, when we will say resistivity, A value is equal to 1 unit only. L is equal to 1 unit only. That means resistivity do not depends on area of cross section as well as length of a conductor. Correct only na? Why? Because it is the equal to 1 only. Okay, resistivity we can define it 1 unit length, 1 unit area of cross section only. 1 unit length, 1 unit area of cross section. That means it is do not depends on any area of cross section as well as length of conductor. Correct? That is why resistivity is depends on only nature of the material, and temperature of a conductor. Correct? It is do not independent of its dimensions. Dimensions mean area as well as length. It is independent of their geometries. Okay, geometry is nothing but area as well as length. So it is a constant. Okay, why? Because area is equal to 1 unit, length is equal to 1 unit. Therefore, so rho is depends on only resistance. Resistance is maximum in resistivity also maximum. Resistance is maximum, resistivity also maximum. Right. So next SI unit. SI unit of rho. Okay, what is the rho formula? Rho is equal to R into A by L. So R resistance is equal to O. A is equal to meter square divided by L is equal to meter. Meter get cancelled. Therefore, ohm into meter is the resistivity, SI unit of resistivity. SI unit of resistivity. Next, dimensional formula. Dimensional formula of rho. So ohm is what? M L square T power minus 3. Yes or no? Ampere power minus 2. So this one only na? So just reverse only. So meter L square, L only. So L into L square, so L cube. Therefore L cube T power minus 3 A power minus 2 is the dimensional formula of rho. Dimensional formula of rho. That is the resistivity. Okay, right. Next. Right. So next question is, on what factors does resistivity of conductors depends? Previous I have given what is that factors affecting the resistance of a conductor. Similarly here also resistivity also depends on some factors. What are the factors of resistivity? What are the factors of resistivity? Right. First factor is nature of the material of the conductor. This is the first one is nature of material of the conductor. Correct only, right? So mean conductors as well as resistors like that will be there. So nature of material of the conductor. Nature of the conductor, for example, copper, aluminum. Next one, tungsten. Yes or no? So tungsten. So next one, nichrome. These and all. So tungsten, nichrome is the good resistor comparatively copper and aluminum. This is the good conductors. These are the good conductors. So tungsten as well as nichrome, such type of conductors are good resistors. That means good resistors are having good resistivity. Right? Comparatively conductors are having less resistance, no? So that's why these are having less resistivity as well as. So these are having good resistance, so that these are having good resistor. That is why here nature of the material of the conductor. Different materials are having different resistivity. Different materials are having different resistivity. That is the point. First point. Next one, temperature. Yes, temperature of the conductor. The temperature can increase mean the resistance should be increased. Resistance should be increased mean resistivity also can increase. But the relaxation time should be decreases. As well as mobility also decreases. mobility. Yes or no? Mobility is nothing but the drift velocity per unit electric field only, right? That means mobility is depends on drift velocity. Mobility is depends on drift velocity per unit electric field. Drift velocity formula what? E by m into tau. So E get cancelled. Therefore, mu is equal to E by m into tau. That means, so mobility is depends on relaxation time. Relaxation time as well as mass also. Remember, if mass is more mean the mobility is less only. Right, but relaxation time and drift velocity both are directly proportional. Mu is directly proportional to the relaxation time. So, by increasing temperature, the relaxation time should be decreases. Relaxation time should be decreased means mobility of conductor also decreases by increasing temperature. Alright, so that is why here remember, so resistivity, resistance both are depends on temperature. The temperature can increase means resistance should be increases. The resistance should be increased means resistivity also can increase. Both are can increase. Right, third point, physical condition, physical and chemical conditions of the material. That means here pressure and temperature as well as impurities. Okay, alloys. If I add some impurities, then what would be happen? The resistance should be increases. Correct? So alloys are having nickel, manganese, the combination of manganese and nickel. Okay, manganese. Like that we are having some. So what is that? Alloys. These alloys are having so more and more resistant power. Resistant is more mean resistivity also more. That is the so physical and chemical conditions of the material. That means impurities and pressure and temperature. So next, presence of impurities. Again, the same direct point. What is that? Presence of impurities. In the presence of impurities, what would be happen? The resistivity should be increases. These are the four factors. So first one is nature of the material. Second one is temperature of the conductor. Third one is physical conditions, physical and chemical conditions like the conditions of the material, and presence of temperature. Presence of temperature. Physical and chemical conditions mean pressure as well as temperature. So as well as impurities also will come, but direct separately I have given. Okay, so that is these four factors. Some extra points also remember. A perfect conductor would have zero resistivity. Remember this point. What is that? A perfect conductor would have zero resistivity. Perfect conductor would have zero resistivity. Similarly, a perfect insulator would have an infinite resistivity. Perfect insulator is have infinite resistivity. Perfect conductor is having zero resistivity. This is the infinite. Next, metals have low resistivity. In the order, the range is 10 power minus 18 ohm meter to 10 power minus 6 ohm meter. This is the range of metals. The resistivity of the metals range is 10 power minus 8 ohm meter to 10 power minus 6 ohm meter. Remember that point. So next one, the smallest resistance are the best conductors, which are having very small resistivity. These are best conductors. Alright, resistivity is less mean that is the best conductors. Similarly, one more point. What is that? The resistivity of an insulator 10 power 8 into 10 power 22 ohm into meter. That is the so range of an insulator. Oh, very high value. Correct one. What is that? 10 power 18 to 10 power 22 ohm meter. That is the resistivity of insulator. Alright, this is the small information about resistivity. So resistivity, what is the resistivity? What is the formula of resistivity? What is the SI unit? What is the dimensional formula? What are the factors of resistivity? Alright, this is a question finished. Next question is, what is conductivity? Previous I have given conductance. Conductance means the reciprocal of resistance is known as conductance. Now similarly, conductivity. Conductivity is nothing but it is the reciprocal of resistivity. The reciprocal of resistivity is known as what is that? Conductivity, which is represented as sigma. So remember here. So what is that? The reciprocal of resistivity. The reciprocal of resistivity is called conductivity. The reciprocal of resistivity is called conductivity, which is represented as sigma. Sigma is equal to 1 by rho. 1 by rho. 1 by rho means conductivity. Correct? So conductivity. This formula, first expression also have. What is that? N E square by M into tau. Yes or no? This is the relation formula. Sigma is equal to N E square divided by M into tau. This one also I have given derivation. First is a question, right? Conductivity. The reciprocal of resistivity is called conductivity. Then SI unit of conductivity, sigma. Sigma means 1 by ohm into meter. 1 by ohm into meter only. So SI unit of resistivity is equal to 1 by ohm into meter. Converting to numerator, it becomes ohm inverse meter inverse. Ohm inverse meter inverse. Right? Ohm inverse. Ohm inverse is nothing but a Simon. Ohm inverse is nothing but a Simon into ohm inverse. One more SI unit. What is that? Simon into meter inverse. Simon per meter. Simon per meter is the SI unit of conductivity. Similarly, dimension formula. So dimension formula is reverse of resistivity dimensional formula. Correct? So what is that? Right. So what I have given? Right. What is that? So reverse of ohm only, right? Reverse of resistivity only, na? Reverse of resistivity. What is that? Ohm into meter. So ohm inverse, meter inverse. Ohm unit, this one all you know. What is that? M L square T power minus 3 into A power minus 2, A power minus 2 into L. So L into L, L cube. L square into L, L cube. Therefore, dimension formula what will come? M power minus 1, L power minus 3, T power 3, A power 2 is the dimensional formula of sigma. What is the sigma? Sigma is nothing but conductivity. Right? And also remember, for insulator, sigma is equal to 0. For perfect conductor, sigma is equal to infinity. And one more small definition also I have given. See once. What is that? Conductivity is the measure of the ability of material. It is the ability of material to conduct electricity. How much electricity is conducted? That is the conductivity. To conduct electricity is nothing but that ability. The ability of material to conduct electric current through it is known as conductivity. Conductivity is nothing but the measure of the ability of a material to conduct electric current through it is known as conductivity. One more definition. Also very small definition. What is that? The reciprocal of resistivity is known as conductivity. So for insulator, sigma is equal to 0. For imperfect conductor, sigma is equal to infinity. Alright, okay. Right. So next, dependence of resistivity on temperature. Now relation between temperature and resistivity we will see. So what is the resistivity and temperature relation? Okay. So you know already the resistivity of the material is depends on the temperature. Correct or not? So the resistivity of a material is depends on temperature. That is why, so small description here. What is that? Consider a conductor consider a conductor. This is the one of a conductor. So at 0 degrees Celsius, its resistivity is equal to rho naught. Now I can increase the temperature. This is the T1 degree Celsius. This is the T1 degree T1. So next T2. T2 is equal to T degrees Celsius I will give you. Okay, at that condition, its resistivity is equal to rho T. The change in temperature is equal to how much? Delta T is equal to T2 minus T1. Then what is the relation between this and all? Okay, so that purpose this one only. What is that? So the this is the initial resistivity. This is the final resistivity. You know, rho T is greater than of rho naught only. Na? Why? Because this is the at 0 degrees Celsius. This is the at T degrees Celsius. The temperature can increase with the resistivity also can increase. The temperature can increase with the resistivity also can increase. Therefore, the change in resistivity means delta rho. Delta rho is proportional to rho naught. Correct? Initial value only. Initial resistivity is more mean. So while increasing temperature, so the final resistivity also can increase. That means change of resistivity also can increase. So the change in resistivity is proportional to rho naught. Similarly, the change in resistivity is directly proportional to rise in temperature. So from equation 1 and 2, what we can add here? Delta rho is proportional to rho naught into delta T. Rho naught into delta T. A proportional constant we will consider as a alpha rho, where alpha rho is equal to coefficient of resistivity. What is that? Alpha rho. Alpha rho means coefficient of resistivity. They will ask question. So find the coefficient of resistivity like that. But in that case, we have to use formula this one only. Alright. So from 1 and 2, what we can write? Delta rho is equal to alpha rho into rho naught into delta T. So now I want to alpha rho. Alpha rho is equal to, so this is not transfer this side. Therefore, what would be happen? Delta rho by delta rho naught into delta T. This is the resistivity, coefficient of resistivity formula. Or else, so delta rho is nothing but delta T minus, that means rho 2 minus rho 1. Correct? Rho 2 is nothing but rho T. Rho 1 is nothing but rho naught divided by rho naught into T2 minus T1. This is the formula. Very, very important formula. So problems they will ask based on this one also. Coefficient of resistivity, you can find it like that. They will ask question. Right, still this one we can give you like that. What is that? Rho T minus rho naught is equal to this one, transfer this side. Therefore, what is that here? So alpha rho, correct? So rho T minus rho naught is equal to, yes sir, delta T I will write the same one. This one transfer that side. Rho naught into alpha rho into delta T. So alpha rho naught transfer that side becomes plus only. Rho T is equal to rho naught plus rho naught into alpha rho into delta T. Therefore, rho T is equal to rho naught of 1 plus alpha rho into delta T. So this is the final temperature. Final resistivity. Final resistivity of a conductor at T degrees Celsius. At T degrees Celsius. Okay. Rho T is equal to this one. Similarly, some graphs. The resistivity of conductor increases by increasing temperature. Correct? The resistivity of a conductor by increasing, the resistivity of conductor increases by increasing temperature. So first I took there copper conductor. This is the copper conductor, Cu. So increases. Resistivity also increase, temperature also increase. Temperature can increase, resistivity also can increase. Similarly, so this is the nichrome wire. Nichrome wire, good resistor. Okay, it is alloy. So nichrome, right? So what would be happen? So here resistivity is a straight line will come. Is a greater than 1 only here. At 0 degrees Celsius, resistivity here 0, but at 0 degrees Celsius this is not a 0, nearly more than 1 ohm into meter. Okay, so here, so will come like that only. So straight line. good resistor is having good resistivity. So temperature can increase, but resistivity also can increase. Similarly, last one, what is that? For semiconductors. For semiconductors, what would be happen? So the resistivity as well as resistance both are decreases by increasing temperature. Temperature can increase, mean resistivity also can decrease. Right? Okay. Right. So previous I had, what is that? The coefficient of resistivity. Similarly, now what is the coefficient of resistance? That means alpha R is equal to, what is the formula? Alright. So temperature, so resistance also depends on temperature only. Na? So that is why now, so what is the question is? So temperature coefficient of resistance. Temperature coefficient of resistance is equal to how much? Alpha R is equal to how much? What is alpha R? Same formula. What is that? Alpha R is equal to delta R by R naught into delta T. Or else alpha R is equal to, what is the formula? So RT minus R naught divided by R naught into delta T. Same description. What is that? The resistance of conductor depends on temperature. The resistance of conductor depends on temperature. Correct, first point. Next, second point. At 0 degrees Celsius, resistance of conductor is R naught. And at T degrees Celsius, resistance of conductor is RT. That is why the change in resistance delta R is directly proportional to the initial resistance of a conductor. Similarly, delta R is directly proportional to the rise in temperature. Temperature can increase, mean resistance also can increase. Correct? So resistance can increase while increasing temperature. So that from equation 1 and 2, we can write delta R is proportional to R naught into delta T. R naught into delta T. Correct? Proportional constant we will consider as a alpha suffix R, where alpha suffix R is nothing but coefficient of resistance. Coefficient of resistance, not a resistivity. Now resistance. Alpha R is equal. Therefore, alpha R is equal to, so delta R divided by R naught into delta T. Correct? Similarly, alpha R is equal to, so this one delta R mean RT minus R naught divided by R naught into delta T. So this is the formula. Still, I want to RT, sir. I want to RT. Just to do cross modification. What is that? RT minus R naught is equal to alpha R into R naught into delta T. Correct? RT minus R naught is equal to R naught into alpha R into delta T. So now R naught transfer to that, so it becomes plus only. Right, now R naught take common. Therefore, RT is equal to R naught into 1 plus alpha R into delta T. This is the final resistance. That means resistance at T degree Celsius. Same graph again. The graph between, so resistors. So temperature along y-axis. So resistance along y-axis, temperature along x-axis. So temperature can increase, mean resistance also increase, but like that only will come for nichrome wire. Similarly, for conductors, copper conductor, their resistance can be increased like that only. For semiconductors, resistance should be decreases. Like that only. Correct? This is the temperature coefficient of resistance finished one. So now small application here. Very, very important problem point of view. So what is that? I took one conductor here. At 0 degrees Celsius, its resistivity is equal to R naught. Sorry, resistance is R naught at 0 degrees Celsius. Now I have given small temperature T1 degrees Celsius. In that case, its resistance is equal to R1. Resistance is equal to R1. Okay. Still, that is a one case one. Next case 2. Case 2 is what? Again, I have applied more amount of temperature. I increases still T2 degrees Celsius. Mean T2 degrees Celsius is greater than of T1 degrees Celsius. T1 degree Celsius. So in that case, its resistance also increases, right? That resistance is R2 ohm. This is the R1 ohm, this is the R2 ohm. What is the meaning of R1 ohm? Resistance of a conductor at T1 degrees Celsius. Similarly, what is the meaning of R2? R2 is the resistance of conductor at T2 degree Celsius. So now for this purpose, what is the change in temperature? R1 minus R0 only. R1 minus R0 is equal to R0 into alpha into T1 minus T0. T0 is equal to 0. I neglect that is. Okay, so T1 I took there. Okay, therefore I want to R1. R1 is equal to R0 transfer that side and R0 take common 1 plus alpha into T1. Alright, this is the equation number 1. Similarly, for this purpose, change in temperature is how much? R2 minus R0. R2 minus R0 is equal to initial temperature is R0 into alpha into T2. So R0 transfer that side, yes. TR2 is equal to R0 into 1 plus alpha into T2. Correct? So now this is the equation number 2. Now question is, what is the alpha? Okay, coefficient of resistance is equal to how much? Coefficient of resistance is equal to how much? Therefore, from equation 1 and 2, now we will do equation number 1 divided by equation number 2. So, R1 by R2 is equal to R0 into 1 plus alpha into T1 divided by R0 into 1 plus alpha into T2. So, R0 get cancelled. So, 1 plus alpha into T1 divided by 1 plus alpha into T2. Then, this one do cross multiplication. R1 into 1, R1. R1 into alpha into T2, R1 into alpha into T2 is equal to R2 into 1, R2. R2 into alpha into T1, R2 into alpha into T1. Okay, na? So now what happened? So this R2 alpha into T2 transfer this side, this is the becomes minus. R1 you can transfer to, that becomes minus. And here also alpha will be there, here also alpha will be there. Alpha take common. Therefore, R1 into T2 minus R2 into T1 is equal to R2, it becomes minus R1. Correct? Then I want to alpha. Alpha is equal to R2 minus R1 divided by R1 into T2 minus R2 into T1. This is the formula. Finish, man. That's it. Right. Right. So till now I have given temperature related all topics. Okay. So this and all you have to listen and you have to remember carefully. Right. Next session I will give some more information. Right. So thank you to one and all. Thank you.